Hi all, in this video we are going to see how to construct a dendrogram in hierarchical clustering. Hierarchical clustering is a type of unsupervised learning algorithm, and here we can create nested of clusters by either splitting or merging the data points continuously in every iteration. There are two approaches. One is called as top-down approach, and which will be called as either a method called as divisive. So here initially all data points belong to a single cluster. Every iteration the cluster gets splitted. At the end every data point, that is each and every single data point, belong to one cluster. And the next approach is called as bottom up approach. So in bottom up approach, every data point or each data points belong to a single cluster initially, and every iteration two clusters get merged based on some criteria. Finally all data points belong to a single cluster. The other name for this is called as agglomerative clustering. So now we are going to construct a dendrogram. The dendrogram is nothing but a tree-like structure which represents the output of the hierarchical clustering. So this matrix is called as a distance matrix, and here we are considering the concept of the agglomerative clustering to construct our dendrogram by using these data points in the distance matrix. So initially we have 5 data points. It means that every data point belongs to a single cluster, P3, P4 and P5. The distance matrix represents the distance between each points with in terms of Euclidean distance. So distance to P1 to P1, that will be 0. Distance to P1 to P2, that will be 3. Distance to P1 to P3, that is 18. And the distance to P4, which will be 10. And the distance to P5, which will be 25. So we may get the points like P1, P2, P3, P4 and P5. So the data points are available, and now we are going to apply some merging criteria so that we try to merge the data points together to form a cluster that will be represented in a tree-like format, which will be called as dendrogram. And to start with, the criteria which we are using for the merging is called as single linkage criteria. So single linkage criteria. So the distance which should be minimum between the data points, that will be considered as a linkage criteria to merge the two data points. So from this particular distance matrix we know that, and another one thing in the distance matrix, it is like a similarity matrix. That is the distance between P1 and P2, and similarly the distance between P2 and P1 both will be same. So it is a symmetric matrix. So all in the top side, which will be same as in the left corner and the right corner. So now to construct this, we have to consider the single linkage criteria. You need to identify which is the minimum distance out of it. So the distance between point P1 and P2 is the minimum. So the thing is, we want to merge the points P1 and P2. So to construct that, we are constructing another one matrix. Initially the matrix size is 5 cross 5. So we have 5 data points. Now 2 data points merged together. So we are getting with the size of 4 cross 4. So we are constructing a 4 cross 4 matrix. And here P1 and P2 together merged. P3 will be similar, P4 and P5. So we are merging P1 and P2 together. Okay, so while we merging, we know that the diagonal values again it becomes 0. So we are just putting the diagonal values are 0. Now we are considering for P3. Okay, so when we come with P3, now the row 1 and 2 get merged. So when we merge, we need to enter any one value. The value what you select is the minimum distance. That's why the criteria comes here, single linkage criteria. So the minimum distance is 18. The same value only we are making here too. And P4, from the P4 we want to merge 1 and 2. So 10 and 13, out of that the minimum value is 10. So 10 will be put here. And 5, 25 and 28, the minimum is 25. So we are making 25 here. Now coming to the next row, the distance between P3 and P4, there is no change in P3 and P4. So it will be 8 and this is 7. So 8 and 7. And come with the distance between P4 and P5, it is 15. So we are making it to be 15. So now we have merged two data points P1 and P2. So now we are moving to the next iteration. In the next iteration, we have to see which is the minimum to merge for the next iteration. So when we go through the next iteration, the minimum is 7. So 7 means we need to merge P3 and P5. So now the matrix become reduced with the size of 3 cross 3. So we have already P1 and P2 merged. Now P3 and P5 get merged and we have P4. So we are merging P3 and P5 together. So now we formed, previous step we have totally 4 clusters. Okay, the thing is P1, P2 together, P3, P4, P5 individual cluster. Now we have, this is 1 cluster, this is 2 cluster, and now we have 3 clusters. So like that we are trying to merge every time the data points together to form this as a single cluster. Okay, so P1, P2, P3, P5 and P4. So diagonal, initially fill it to 0. So now go with P3 and P5. Okay, so now we are merging P3 and P5 we are getting merged. That will be entered for P1, P2. So in this particular row, now we are merging the column P3 and P5. So any one value to be taken. So the minimum value is 18. Then P1, P2, we are having the next value P4, that is similar. So you put that. So here also 18 and 10. Now go to this row. Now we are merging P3 and P5 get merged. That we need to enter for P4. So P3 and P5 for the column P4. So out of 8 and 15, the minimum is 8. So we are making the thing is 8. The next iteration, we need to further merge the data points. We need to identify which is minimum. So now the minimum is this. So already 3 and 5 get merged. Along with that, we are going to merge P4. So this everything together get merged. We are getting only 2 clusters. So we are constructing the matrix which is of 2 cross 2. The first cluster having P1 and P2. Second cluster having P3, P5, which will be merged with P4. So P1, P2, now P3, P5 and P4. So now put the diagonal, go to the row P1 and P2. We are merging this particular 2 columns out of this which is minimum. So 10 is minimum. So now the final step, we are getting everything will be get merged together. So we are getting the number of clusters 1. Okay, so here we are not giving any initial instruction that how many clusters we need, but when we use k-means algorithm and the other clustering algorithm, initially itself we have to tell how many clusters we need to divide our data. But here we are not giving the instruction initially how many clusters we need, but every iteration we are merging the data points and getting the different number of clusters. So now this thing we are going to represent it in a dendrogram, which is a tree-like structure. So initially the data points whichever we have merged together. So initially we merged the data points P1 and P2. So P1 and P2. So these two get merged with the value of, okay, so in this particular minimum distance of 3. You can see here initially we to choose the minimum distance is 3. And then the next iteration we have merged P3 and P5. So P3 and P5, which will be merged together with the distance of 7. And in the next iteration, we have merged P4 together. So P4, which will be in the distance of 8. In the last iteration, everything get merged together with the distance of 10. So this is the formulation of the dendrogram. Okay. So now you need, for example, I am telling I need the number of clusters I need is 2. Okay. So what we can do is we can find out the cut points. For example, I am making the cut point is 4. When I make a cut point is 4, I am trying to put a cut here. This time I am getting, this is one cluster, this is second cluster, third cluster, fourth cluster. I am getting 4 clusters. And now I am putting the cut point is 7.5. So when I make a cut point of 7.5, I am getting 3 clusters. So the clusters having the data point P1 and P2 together, and then we have the next cluster P3 and P5 together, and then P4. So like that, if I put a point in 9, if I put a cut point in 9, I am getting 2 clusters. So this cut point only decide how many clusters you need to get in that particular cut, so that you will get with the number of clusters. Now we are going to see another one example with the distance matrix. There may be a question that you may given a points like this: P1 3,5, P2 5,6 and P3 4,8. Okay, so like that you will be given some points 5,8. And then P5 you may get some 7,11. Okay, so now this will be given as an input. For that you have to construct a dendrogram. So that what we have to do is we have to first calculate the distance between every data point. So we need to construct what is the distance between P1 to P2, P3, P4 and P5. Then for P2 you have to construct P3, P4 and P5, because we know already P2 to P1 we already calculated. Then P3 you have to calculate the distance to P4 and P5, and then last P4 we have to calculate for P5. This all you have to use the Euclidean distance formula to calculate the distance, so that only construct your distance matrix. Then you have to follow the same step to construct your dendrogram. So now we'll just follow this. We'll just go with what is the minimum distance first. The minimum distance is 0.3, which will be merging the data points P3 and P4. So construct a 4 cross 4 matrix. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we have P1, P2, P3 and P4 merged together, and then P5. Similarly, P1, P2, P3 and P4 merged together, and P5. Put everything, fill first the diagonal. Now go with P1 to P2, no change. Then P1, P3 and P4 merged together, so minimum is 0.46. Then P1 to P5 0.81. The same value you repeat it since it is a symmetric matrix. Okay, so enter. Now go to P2. P2 combined with P3 and P4, the minimum is 0.61, and P2 to P5 the distance is 0.32. So this also you write it here. And next go with P3 and P4, this two merge together. We want to consider what is the value for P5. So take this two, find the minimum value, that is 0.35, and here also 0.35. So the first step, P3 and P4 get merged. So now we are going with the second iteration. The second iteration, the minimum value is 0.32. So now we are trying to merge P2 and P5. So now the matrix become 3 cross 3. So we are putting P1, next one is P2 and P5, the last step is P3 and P4. Here also P1, P2, P5 and P3, P4. Fill the diagonals, go with P1, check with P2 and P5. Out of that the minimum is 0.81, here the same value 0.46, 0.81, 0.46. So go with P2 and P5. In that you need to put with P2 and P5, you need to put for P3 and P4. So P2 and P5, in that P3 and P4. Take the minimum value, that is 0.35. So 0.35. So now we have ended with the next iteration. Now we are going with the next step of merging. We need to identify which is the minimum, 0.35. So we need to merge P2, P5 with P3, P4. So now construct a 2 cross 2 matrix. The first value is P1, next value is P2, P5, which will be merged with P3, P4. So here also P1 merged with P2, P5, which is merged with P3, P4. So diagonal is 0. Now go with P1. We want to merge this 2. So out of this the minimum is 0.46. So 0.46. So we have ended up the last step. The point P1 also merged with the cluster. So now we need to construct a dendrogram. The first step, what we have merged together, that is P4 and P3. So this two get merged at the point value of 0.30. And now the next thing get merged is P2 and P5. So which get merged at the point of 0.32. And the next step, this together get merged with the point value of 0.35. And the last step, we have the P1. The last point is P1, which get merged together with all your data points at the point of 0.46. So I can make a cut in anywhere so that I can know how many clusters. If I make a cut here, I am getting 3 clusters. Hope you got an idea how to construct a dendrogram from the given distance matrix in the hierarchical clustering. Thank you.